Hello. So what we're trying to do here is to graph x is greater or equal to 2 on the number line, but using GeoGebra. As you can see in this picture here, I'm using Maple to write the text. Maple does cost money, so we're not going to use Maple to draw the graph of x is greater or equal to 2. We're going to use the free software GeoGebra. And so let's start, and the next slide will be GeoGebra in full action. Thank you very much. So to hide the y-axis, we just right mouse click on that main pane area. Once we've opened up the box, we select the y-axis tab, and down in there is the show object, and we just uncheck that, and that'll turn the y-axis off. Thank you. Yeah, so to do the x is greater than or equal to 2, we just follow these steps as shown here, and that will give you the graph. So that's one way that the kids could do it, but generally the consensus is that they shouldn't be exposed to doing it, and we do it for them, so this is what we have to do. Okay, so this is a graphics view screen here from that right mouse click we did earlier, and what we do here is just uncheck that box on the grid for y-axis only, and that will turn it off. Great. And voila, there it is, and there's no y-axis showing here, so that's what we wanted. And we'll continue now. So type in u equals unit vector, open the square bracket, x-axis, capital A there, capital U for unit and capital V for vector in that word, because it's case sensitive, it'll bring the command up. We hide the vector u by right mouse clicking on the vector itself and deselecting by clicking the show object. Okay, to change the ray's color and thickness to your own personal taste, right mouse click on the ray itself and choose a color. I've chosen red, and I've increased the thickness just to reinforce what we're talking about, to show that line clearly x is greater than or equal to 2. Okay, and the text toolbox is actually the input command, as far as I know, and it's a standard expression that has to be entered in such a way into that input box down the bottom, and that will give you the text, and you can drag it over across point A, and that will give you the text x is greater than or equal to 2, which we want positioned above that red part of the line. So just to finish it off, we grab the x is greater than or equal to 2 text box and drag it over on top of that red line there, and that'll finish the graph off for the kids. That's what they want to see. In this next example, we're looking at GeoGebra, and sometimes it's not a great idea to use it. The students might get a bit confused with its output. If I look at version 3.2, have a look at x between the value of -6 and less than or equal to 9. The output of GeoGebra in that version is not ideal, and probably should be avoided. We'll have a look at the next slide. As you can see, it's not a too good a look, probably confuse some of the students, so this is one example where we wouldn't use GeoGebra to reinforce mathematical concepts through a visual aid. Yes, well in this example, we're using GeoGebra version 4 beta, and we're looking at the function basically y equal to 3 and another function y equal to x plus 3. We're looking at the area trapped between those two lines, and we have to make GeoGebra understand that's what we want. So there's a little bit of coding needed for that to happen, and you can see the code at the top. Probably not that clearly, but we'll go and have a look at what the output is of this. And as you can see, this type of output is ideal for the students to see very clearly with the different colors, they can see where that area is trapped between those two lines, and that's what you're looking for. In this next example, we're trying to work out the area of a polygon. You need to type in text, capital T-E-X-T, open square bracket, inverted commas, plus poly1, close the square brackets, into the input part down the bottom of GeoGebra to get the area up on the left-hand pane down the bottom. And so here's the output of that. There's the rectangle ABCD, and poly 1 equals 10. That's the area down the bottom on the left-hand pane. And that's what we're after.
We can use the rotate function to move objects around the plane. By typing rotate with a capital R, open square bracket, poly 1, comma, angle close bracket, we can rotate any trapezium or any polygon into another quadrant.
It looks as GeoGebra is using radians for the rotation, and the reflection's done around a point. I'm having trouble doing reflection around an axis, which is what I wanted to do. But anyway, that's what it's doing, and we'll have a look at the next slide. And in this example here, we've got a triangle that's been rotated around so many radians, and the triangle's also been reflected about a point B. The angles have been put in, so once you've created the triangle using the polygon icon, fifth from the top, there is also an angle icon 3 more down to the right, and that will, once you've clicked that and clicked inside the triangle, that'll put all the angles in, and then you can just drag the angles outside of the triangle for a better appearance.
We can use the ray, circle and angle commands to help us rotate the ray around a circle, showing the angle subtended with a positive axis. This can help in such areas as trigonometry.